Hi friends, in this video we are going to discuss about general principles and processes of isolation of elements. And this video is mainly for the students who are preparing for competitive exams. In the previous video, we have discussed what is mineral and what is ore. Minerals are the elements or compounds that are naturally occurs in earth crust, while ores are the minerals from which the metal can be extracted. So we can say that all the ores are minerals, but all minerals are not ores. That means it is not possible to extract a particular metal from all minerals. The metals can be extracted only from a particular mineral, which is the ore of that particular metal. There are different steps involved in the extraction of metals from its ore. It includes concentration of ore, isolation of metal from concentrated ore, and purification of metal. Concentration of ore means the removal of gangue from ore. Gangue is the impurities that are contaminating the ore. Different methods are used for this concentration process, that are gravity separation, magnetic separation, froth flotation method, and leaching. The gravity separation is based on the difference in specific gravity between gangue and ore particle. In this, the powdered ore are fed into a stream of running water so that the lighter impurities are washed away and the heavier ore particles are left behind. It is mainly used for the concentration of oxides and carbonate ores. Next one is magnetic separation. It is used for the separation of magnetic impurities. Impurities that are magnetic in nature are passed over magnetic roller. Ore and magnetic impurities are collected as two separate heaps. It is used for the concentration of hematite, which is the ore of iron, and chromite. Next one is the froth flotation method. It is based on the difference in wetting properties of ore and gangue with water and oil. When a mixture of powdered ore along with some water and little pure oil is agitated by a blowing air, a froth is formed. In this froth, the lighter ore particles are carried out in the surface by foam and heavier impurities will be at the bottom. Next, final one is leaching. Leaching is a chemical process in which the powdered ores are treated with the suitable reagents so that the ore get dissolved in the reagents and the impurities remains undissolved. This undissolved impurity can be removed by filtration, while those ores are recovered from the solution by suitable chemical method. This process is mainly used for the concentration of aluminium, silver, gold, etc. After the concentration, the next step is the isolation of metal from the concentrated ore. It involves two steps: conversion of concentrated ore into oxide and reduction of the oxide thus obtained into corresponding metal. The conversion of concentrated ore into its oxide is done by calcination and roasting. Calcination is commonly used for the hydroxides and carbonate ores, and this process involves the heating of ore below the fusion temperature in the absence of air in a reverberatory furnace. An example is the aluminum hydroxide can be converted into aluminum oxide by calcination, and also calcium carbonate can be converted into calcium oxide. Roasting is used for the sulfides. It involves the heating and regular supply of air below the melting point of metal. An example is the conversion of zinc sulfide into zinc oxide. Second one is the reduction of this oxide into corresponding metal. It involves chemical reduction, auto reduction, displacement method, electrolytic method. The chemical reduction involves reduction with the carbon, reduction with the hydrogen, aluminothermic reduction or Goldschmidt thermic process, and reduction with the sodium and magnesium metal. An auto reduction, the metal is obtained either by simple roasting or by the reduction of its partially oxidized form. In displacement method, the metals are reduced through displacement by a more reactive metal from the complexes. Finally, the electrolytic method, which is used for highly electropositive elements of group 1 and 2, which are found as chloride or oxosalts. These oxosalts are converted to chloride later. This electrolysis is done in fused or molten form. In this, the metal gets deposited at cathode. After the isolation, the final step is the purification of metal. Some purification methods are distillation, electrolysis, liquefaction, sound refining, and vapor phase refining. Distillation is used for easily volatile metals like zinc, cadmium, mercury, etc. Electrolysis is used for metals like copper, gold, silver, lead, etc. And in electrolysis, the net result is the transfer of pure metal from anode to cathode. In liquefaction, the impure metal can be made to flow on a sloping surface and thus separated from higher melting impurities. It is mainly used for the purification of tin, bismuth, lead, mercury, etc. In sound refining, the metals of high purity are obtained. It is based on the fact that the impurities are more soluble in melts than pure metal. It is used for the purification of silicon, germanium, boron, gallium, indium, etc. The final one is the vapor phase refining. The examples for vapor phase refining are Mohs process for the refining of nickel and Van Arkel process for refining of zirconium. Now let's see some metals, their ores and how they are extracted. First one is aluminium. Aluminium usually exists in the form of bauxite, which is the ore of aluminium. And the method of extraction of aluminium from bauxite is electrolysis of Al2O3 dissolved in Na3Lf6. Next one is calcium. Its ores are fluorospar, limestone, gypsum. And the calcium is extracted from this ore by electrolysis. Next, magnesium. Magnesium occurs as magnetite, carnallite and dolomite. It is extracted by electrolysis. And sodium exists as common salt and silly saltpeter, and it is extracted from its ore by electrolysis. Copper exists as copper pyrite, malachite, copper glans and cuprite. These are extracted from this ore by partial oxidation and subsequent reduction. Then iron exists as hematite, magnetite and iron pyrite. It is extracted from this ore by reduction of oxide with carbon monoxide and coke. Next is zinc. Zinc exists as zinc blende, calamine and zincite. Then the zinc can be extracted from its ore by roasting followed by reduction with coke. Lead exists as galena and anglesite, and it is extracted from the ore by oxidation followed by reduction with the carbon. Manganese as pyrolusite and extracted by oxidation in 2 stages. Silver as native silver, horn silver, silvery glans, and it is extracted by cyanide method in which the oxidation followed by reduction with zinc. Tin exists as cassiterite and it can be extracted by carbon reduction. Chromium as chromite, it can be extracted by aluminothermic process. And finally, the mercury exists as cinnabar, it can be extracted by self-reduction between HGS and HGO. Thank you.